All right, so we're gonna start, and then if anybody joins in, then we'll just keep going from there. But then just let me know if you guys have questions. All right.
Okay.
So if we take a look at the formative that you guys have been working on, okay. So the formative from yesterday, it was talking about two-step stoichiometry. And so when we think about two-step stoichiometry, there's going to be multiple steps that we have to take during this to understand the information, right? So to get our final product. So if we look at the problem, it says that how many grams of this aluminum sulfate, so Al2SO43, will be produced if you react 5.13 moles of H2SO4 with some excess aluminum. Okay, so what that means is the first thing we're going to do is we're going to balance our equation. All right, do you guys remember how to balance the equations?
Yes.
Awesome. You guys want me to go through balancing the equations?
No.
No? All right. So if we balance this equation correctly, what we should have gotten is 2 moles of aluminum, or 2 aluminum in front, with 3 H2SO4, and we should have gotten 1 aluminum sulfate and 3 hydrogen. Okay? So that was our balanced equation that we should have gotten during this problem. Okay? So when we do this, okay, the next thing that we're going to do is we are going to determine what our problem is asking us to go from and what we're trying to get to. So the start of our problem says that we're trying to start with 5.13 moles of aluminum, moles of H2SO4. So 5.13 moles of H2SO4. And what does it say that we want to get to by the end?
Al2SO43.
Perfect. It says we want to get to grams of Al2SO43. And so now we need to determine, can we go from moles of H2SO4 to grams of Al2SO43? Is it possible to go from moles of one compound to grams of a different compound? Before break, were we ever able to go from moles of one compound to grams of a different compound?
No.
No. So we can't go from moles. We can't do this type of problem with one step because we can't go from moles of one compound to grams of a different compound. Do you guys remember from before break what we could do? So we could go from moles of something to what? With our conversions from before break, what could we, when we started with moles, we could go to what other units? Do you guys remember?
No, I don't remember.
Joe, Daniel, do you guys remember?
Nope.
No? All right, so from before break, when we started with moles of something, we had 2 options. So I'm just going to write them up here. Okay, so our 2 options were, we could go from moles of compound A, let's just call it, to moles of compound B. So we could go from moles of one compound to moles of a different compound. And we can go back and forth. We can go in either direction. The other thing we could do is we could go from moles of this compound A, we could get to grams of this compound A. So we can go from moles to grams, or we can go from moles to moles. Do you guys remember how we can go from moles to moles, or how we can go from moles to grams? Do you guys remember what those are called? Either of them? Does anybody remember what they're called? Anybody have a guess? All right. So for moles to moles, do you guys remember the mole ratio? Do you remember?
Yeah.
Do you guys remember hearing about the mole ratio at least?
Yeah.
All right. So we're going to use the mole ratio to get from moles of one compound to moles of a different compound. And do you remember where we get the mole ratio from?
The periodic table.
And so that one's not from the periodic table. Where's the other place we can get something from? Do you remember?
No.
All right. Joe, Daniel?
I'm trying to think, but no, like break hit and everything went up my head.
All right, that's okay. We're going to get it from the balanced equation.
Oh yeah.
So we're going to get this one from the balanced equation. So our mole ratio comes from our balanced equation. And do you remember how to get from moles to grams or from grams to moles? Do you remember what you have to use? I know we were talking about this earlier. We're going to use our molar mass. Do you guys remember that one?
Yeah.
All right, where do we get the molar mass from?
The periodic table.
Perfect. This one's from the periodic table. So now that we remember that from moles of one compound to moles of a different compound, we use the mole ratio. And from moles of one compound to grams of that compound, we can use the molar mass. We're going to look back at our little cheat sheet over here. So our little arrows over here. We're starting with moles of a compound. So now we know we can either go to moles of a different compound or we can go to grams of a compound. So, do you think we want to go from moles of H2SO4? Do we want to go to moles of a different compound, or do we want to go to grams of H2SO4?
We want to go to grams.
We want to do grams of H2SO4?
His audio's out.
So we go from mole. And we now go to grams of Al2SO43. One second, guys. Apparently, I'm cutting in and out, so let me switch my audio to a different spot. All right. All right. Can you guys hear me now?
Yeah.
Yep.
Perfect. Okay. So now, if we start with the we went from moles of H2SO4, went to grams of H2SO4. Can we go from grams of H2SO4 to grams of Al2SO43? Do we have a conversion up here that gets us from grams to grams?
Molar mass.
So the molar mass, let's look at it. We start with grams of one compound. We can go to what using the molar mass?
Moles.
We would go to moles of that compound. So do we have
Yeah.
anything else that uses grams of one compound to grams of a different compound?
No.
No. So we can't do this right here because we can't go from grams to grams. So this is impossible. Because remember that moles are the only way to convert between two different compounds. So we don't want to convert. We don't want to do this right here. So we don't want to get to grams of H2SO4. So what are we going to do instead? If
Could
we're
we
not going to go to grams of something, we're going to go to what?
Moles?
We're going to go to moles of something.
So could we convert AL2 to moles?
We would go to moles of Al2SO43. Perfect.
Because that's molar mass.
Now, if we get to moles of Al2SO43, what can we do now?
Convert grams or moles. to the
Perfect.
other
We can
one.
go from these moles of Al2SO43. Now we can go to grams of Al2SO43. Because we can go from moles to grams of the same compound. All right. So now let's think about this, okay? If we are in moles to moles, okay? So this first step right here, step one right here. What are we going to use to go from moles to moles? What do we say we have to use?
Molar ratio?
Perfect, the mole ratio.
It's a word more.
You guys need me? I'll be outside.
Yep.
You know
We're
your
using
schoolwork
the
and
mole
something
ratio right here to go from moles of one thing to
Yeah, I got
moles
it.
of a
Move the shoes, move all the shit.
Where do we get the mole ratio from again? Where do we find our mole ratio again? Do you guys remember?
The
Periodic
balance
table.
equation.
Oh, no, yeah,
The
balance.
periodic table is not yet. The balanced
No.
equation.
Balance equation, yeah.
So now if we're in moles of Al2SO43, if we're trying to get to grams of Al2SO43, how we go from moles to grams of the same compound?
The periodic table or
We're going to use the periodic table, and what are we going to use from the periodic table?
Molar mass.
Perfect. All right. So now that we have our setup, we know our steps 1 and step 2. Now, what we need to do is set up our railroad tracks. So because we have 2 steps, we need to have 2 sets of railroad tracks. The step 1 is going to go right here. Step 2 is going to go right here. What goes in right here?
the given? Not the given.
The given. Perfect. And our given was what?
513 moles of H2SO4.
5.13 moles of H2SO4. So now our step 1 is getting from moles of H2SO4 to moles of Al2SO43. If we're going to do that, how do we go from moles of H2SO4 to moles of Al2SO43? What do we have to use again?
The balance equation.
We're going to use our balanced equation. We're going to find that mole ratio. So let's look at our balanced equation, and let's figure out our mole ratio right here. The mole ratio. So we have our mole ratio. So can anybody tell me how many moles of H2SO4 we're going to start with?
3.
Perfect. 3 moles of H2SO4. And where'd you get those 3 moles from?
The balance equation.
Perfect. You got them from right there. That coefficient in front of the H2SO4. How many moles of Al2SO43 are we going to make?
1.
Perfect. Just the 1 mole of Al2SO4 3. And we get this 1 from right here. All right. So now we have to decide what goes on the top and what goes on the bottom of that first line. If we're going to put our mole ratio in there, what are we going to put on the top of that line and what are we going to put on the bottom of that line?
On the top, AlSO4.
Perfect. We're going to put 1 mole of Al2SO4 on the top. And that means on the bottom, the 3 moles of H2SO4. Why do we put the 3 moles of H2SO4 on the bottom?
To
To
make it
cancel out.
Perfect. So we want these units right here to cancel out with these units down here, which means we have to put 1 on the top and then 1 on the bottom of the next line. So now we're in moles of Al2SO4. We've done step 1 over here. So now we're here in moles, which means what's our next step?
Molar mass.
We're going to use our molar mass to go from what to what?
Moles to grams of
Moles to grams.
Al2S.
Perfect. So now we have to find our molar mass. I'm going to do that one right here. So to find our molar mass, we have to use our periodic table to find the molar mass of aluminum. We have sulfur and we have oxygen here. If we're looking at our periodic table, there are 26.98 grams per mole of aluminum. We get that number from right here on the periodic table if we're looking. Okay. We have sulfur, which is 32.06, and we have oxygen, which is 16. Now, if we look, how many aluminums do you have in this compound?
2.
We have 2, so we got to take this and multiply it by 2. How many sulfurs do you have in this compound?
3.
You have 3 because this 3 distributes into both, the O and the S. So we have times 3 here, and how many oxygens do you have?
12.
You have 12 because it's multiplication, so we do 3 times 4 to make our total of 12 oxygens. So if we do this math, we have 53.96 plus 96.18 plus 192. And if we add these 3 numbers together, we get a total molar mass of 342.14. And this, what are our units for this? Do you guys remember?
Isn't it?
Moles? Or
We're,
Amaze balls.
no,
so
grams.
we're close. It's grams of aluminum. And that equals what? Because this equals something. The 342.14 grams of aluminum sulfate equals what?
Molar mass.
So it's our molar mass, which means that it has to equal some number of moles. How many moles is this going to equal?
Isn't it 1 mole?
It's always going to equal 1 mole. So our molar mass always equals 1 mole. So now we've created a new conversion factor to use in our table. All right. So now we have on the top of our line, we have 1 mole of aluminum sulfate. What do we put on the top of the next line? What do we put on the bottom of the next line?
The 342.14 grams goes on the top of the aluminum sulfate. Or and then the 1 mole goes on the bottom.
Perfect. That way our units of moles of Al2SO43 get canceled, and we're left with just grams of aluminum sulfate. So now our last step here is going to be to multiply everything on top together and multiply everything on the bottom together. So we're going to do 5.13 times 1 times 342.14 And it's all going to be divided by the bottom, which was 3 times 1. When we do that math, we should get something around the answer of 585.06. And what are my units going to be for this one?
Grams of Al2.
Grams of-
Al4.
Perfect. All right. So what we're going to do is I'm going to have you guys do the second one. I'm going to have you guys try it again on your own now that we've gone through the first one. Okay. So we're going to have you try that one on your own later because I want to go through one more thing before we leave, because I actually have to go to another class in about 7 minutes. So before we leave, I want you to have one more piece of information just so we can do one more thing later. So other thing we're going to do today is this worksheet. It's 2 questions, okay? So this one is going to go a little bit further, okay? So this one is actually, instead of having 2 steps, this one's actually going to be 3 steps, okay? So before we start, we're going to balance this equation, okay? So let's balance the equation. Do you guys think you can balance that on your own?
Yeah.
All right, balance that equation and let me know when you have it.
I have it.
All right, Joe.
It is 2 on NaCl,
Perfect.
1 on CaSO4, 1 on Na2, and then 1 on CaCl.
Perfect. All right, so we have our balanced equation. Now let's take a look at what this problem says, okay? So it says how many grams of CaCl2 will be produced when 75.6 grams of NaCl. So we want to go from grams over here to grams over here, all right? So we're starting with grams. Of NaCl, and then we're trying to get to grams of CaCl2. Now, do you guys remember the 2 conversions that we know?
Yeah.
We can go from moles to what?
Moles of a different
Moles.
one.
Perfect.
And
We
then
can go
moles,
from moles to moles of something else. Or,
moles of grams.
what's the other one? Moles to grams. Oh. So, if we're looking here, we talked about this before, but can we go from grams of one compound to grams of a different compound?
No.
No.
No, we cannot. So instead, we're going to go from grams to what?
Moles.
2 moles.
Perfect. We're going to go from grams to moles. We're going to go from grams of NaCl to moles of what?
NaCl.
Perfect. These would be moles of NaCl. Okay. Moles of NaCl to grams of CaCl2.
Yes.
So you can go from moles of one compound to grams of a different compound?
Oh, no.
So
So we
CaCl
can't
would
do
have
that.
one mole.
So we need to get
Oh.
to moles of CaCl2. So can we go from moles of NaCl to moles of CaCl2?
Yeah.
So we can do that. So now we're going to go to moles of CaCl2. Now can we go from moles of CaCl2 to grams of CaCl2?
Yes, technically.
Yes, we can. Perfect. All right, and one last thing I want to ask before we sign out here. Okay, so if we're starting with grams of NaCl, how do we get to moles of NaCl?
Oh,
What do we have to use?
You find what is it called?
the balance equation, right? You use balance
So that
equation.
one's not yet.
It's the molar mass, right?
It's the molar mass. And we find the molar mass where?
On the periodic table.
Perfect. On the periodic table. And we're going to use the molar mass of what compound?
Oh my bad.
What are we going to use the molar mass of?
NaCl.
Of NaCl. Perfect. All right. Now, how do we go from moles of NaCl to moles of CaCl2? What do we have to use?
Mole ratio.
The mole ratio. And where do we get our mole ratio from?
Balance equation.
We get that one from the balanced equation. Perfect. And then last but not least, from moles of CaCl2 to grams of CaCl2, what do we have to use?
Molar mass.
We got to use our molar mass, and it's the molar mass of what this time?
CaCl2.
Perfect. All right. Do you guys know how to find the molar mass?
Yeah.
Do you know
Yeah.
how to find the mole ratio?
Mm-hmm.
Yeah.
All right. You should be able to set up these problems now. Do you guys think you can do it?
Yeah.
Perfect. All right. So I have to go to my other class, but I'm going to take this video and I'm going to have it the recording. I'm going to put it on Canvas. And so you guys should be able to see it. All right. So then you'll be able to see it and go back if you need to. And then I should have another video on later today that goes through the entire worksheet here. And the answer key will be posted tomorrow morning. Okay?
Okay.
Any questions before I have you guys leave?
No.
No? Joe, Daniel?
Now I'm good.
All right. All right, guys. Then I have to run to a different class. But
What is
have a
that?
good rest of your day. Was what?
There's sirens.
Yeah. Anybody else see that?
It's the first Tuesday of the month.
Oh.
I'm like, are we gonna die from a tornado? Hold on. All right.
All right, guys.
Okay.
I'm gonna kick you out.
Yep. Bye-bye.
Bye.
Bye, guys. Man, so many people.